Yes, folks, we're back with the next part of this exercise 6.5 where we are going to take up the maximum and minimum problems. Let's see what it says. Question number 2 says that find the maximum and minimum values, if any, for the function that's given by. So the function, it's not like though the style of working is exactly like the question number 1, but here the function's nature is changing. In the earlier one, we used to it was more graphical. We could understand the function with the help of the graph, and then we could get the answer algebraically. Now here it is very algebraic, so we are going to mostly get the restrict our answers to the algebraic part of it. So it's like the previous question only. They are asking us to find out the maximum and minimum values. Not that it will be existing every time. If it is existing, then we are supposed to find the maximum and minimum values. That's what the problem is saying. So let's go to the question number 2, sub question 1, which says that f of x is modulus of x plus 2 minus 1. So it says that this is the question, modulus of x plus 2 minus 1. Yeah, so in order to get the working for this, always as we did before, that's going to be your strategy, that you're going to catch hold of the positive or the negative part, and from there you're going to develop the function, and then you're going to check out whether what is the maximum and minimum value. Same thing is going to happen here. The function f of x is defined as modulus of x plus 2 minus 1, where modulus of x plus 2 we all know is always going to be positive. Irrespective of any value of x, the modulus value is always going to be positive. So that we are going to take care of. We can write probably like this. We know that modulus of x plus 2 is always a positive quantity. And in order to reach the function, we will subtract 1 on both sides. So we will get 0 minus 1. As a result, we are getting x plus 2 minus 1 greater than or equal to minus 1, which is f of x. So f of x is greater than or equal to minus 1, which clearly tells that the minimum value is going to be minus 1. We cannot predict the maximum value, because as we substitute the values, we will observe that as we keep on substituting values, the values of the function is also keeping on increasing. For you to get yourself convinced, maybe we can say also you can take the value of x as maybe 10. So your f of 10 value is working out as, what is it? F of 10 is 10 plus 2, which is minus 10 plus 2 minus 1, 12 minus, of course it's modulus, so 12 minus 1, it's 11. You take x as 100. It is f of 100 is 100 plus 2, 102 minus 1, 101. So you could take like 1000, it's going to rise. So the value is keeping on rising. That's how we decide that there's not going to be a maximum value. Minimum value minus 1 is there. So therefore, the minimum value of f of x is minus 1, and maximum value does not exist. Now, why we say it is not existing? Because we try to look at some of the values like this, and we observe that as we keep on increasing the values, the function's value is also increasing. So we are not able to tell a clear value of the maximum. It's not existing. Depending on the value of x, the more higher the function's value is also changing. So that's how we deal with such problems. We'll take the second sub question also. Let's see what it says. That's also of the same nature. G of x is minus of x plus 1 plus 3. Minus, how I have to write it down. Modulus of x plus 1 plus 3. Now it's going to be the same logic as the before one, where there is a modulus. So that is what we are going to take care of. We know that modulus values are always positive. So modulus of x plus 1 is positive. But this is a minus of modulus of x plus 1. So when we multiply minus, we know that it's going to be less than or equal to 0. In order to reach to the function, we require a plus 3. So let's add 3 to both sides. So this is the function g of x, and we are getting that g of x is less than or equal to 3 means 3 is a maximum. Minimum value, it will keep on changing. As you take lesser and lesser values of x, the g of x values also keeps on reducing. Just for you to get yourself convinced, you can take maybe x as minus 10. Look at the gx value. It will be minus 10 plus 1. Yeah, minus 10 plus 1 plus 3. So that's minus 9. Minus 9 in modulus is 9. So minus 9 plus 3 is minus 6. So also minus 100. See what's the value? Minus modulus of 100 plus 1 plus 3. 100 plus 1 is 101. 101, sorry, it's not it's minus 100 plus 1. So that's minus 99. Minus 99 in modulus will become 99. So overall it's going to be minus 99. It's going to be minus 96. So we see, it keeps on increasing. As you keep on substituting higher and higher values, the value of x is keeping on increasing. This part is not required, but it's only for to get ourselves convinced that yes, it does happen. We tell like that. So that will help us to get the maximum and minimum value. So here we have the maximum. The maximum value of g of x is 3. And the minimum value does not exist. That's how it is. The maximum is there, but the minimum does not exist. And why it does not exist, we got ourselves convinced by taking some of the examples. So that'll be all for this video, because they both are simple problem, same problem. So we have done it like that. Now with more problems, it meet in the next video. Thank you.